This is 3.2a, Measures of Dispersions. Dispersion is just variation of scores. So here we're talking about times that it takes Jose to get to work and times that it takes Rita to get to work. And who would be the best person to ride with. So we're going to use statistics to make our decision. So the first thing that you want to do is you want to consider the central tendencies, which is the mean, the median, and the mode. So we can put this into into edit. So we go to edit and we put in our data 25, 27, 28, 25, and you do that by hitting the number and hit enter, the number and hit enter. And then I went ahead and put Rita's in to my list 2. So now we can go out of that and we use to find the central tendencies, the mean, median, and mode, the 5-number summary. You do stat, arrow to calc, 1, and we have to tell it list 1, so second L1. Now some of you, your calculator is going to look different, but you're still going to hit stat calc 1 for one variable statistics, and then it's going to say list and frequency, and you just leave frequency blank, go on down and calculate, and you should get the same thing that we have here. So our X bar is the mean, this is standard deviation, this is population standard deviation, this is their 6 pieces of data, there's the minimum, the Q1, medium, Q3, maximum. That's the smallest number, the biggest number. And we're going to be using those a little later on. And Q1 and Q3, we're going to be using those a little later on. But right now we need the mean, which is 25, the median, which is 25, and then we can look at our data and say, okay, there's 2 25s, so that's the most used, so 25 is also the mode. To pull up Rita's information, we do stat, calc, 1, and this time I have to tell it list 2, so second number 2. If you have the other calculator, you're going to have to change that to second 2, which is L2. So when you hit enter, you see that the mean is 25. You see, if you scroll down, here's the other calculator. I don't have the data in here, so I'm not going to get this information. But this is what your calculator will look like. It'll say list, and you put L1, which is second 1 or second number 2, whichever list you need. You skip over frequency. We're not going to use it yet. You go to calculate, and you hit enter, and it will put this on your screen. So we see here that the median is the same, it's 25. If we look at our data, the mode is 25. And so we see here, all of these are 25, all of these are 25. So how does the data compare? Well, they're all exactly the same. So can we tell from this data who's best to ride with? Nope, not yet. So here, the range is the distance between the calculated maximum and minimum. So the maximum number for Jose is 28, and the minimum is 22. So 28 minus 22, which is 6. So the range for Jose is 6. The range for Rita is 39 minus 11, which is 28. So what that's telling us is between the quickest time she got there and the latest time she got there was 28 minutes. The difference in those two times is 28 minutes. The difference in the times that Jose got there was 6 minutes. So from the longest that it took him to the shortest time it took him was 6 minutes. There wasn't a whole lot of difference, a whole lot of variation, as was there in Rita's time. Standard deviation is the average distance of values from the mean. And we can get that from here if we're talking about sample or if we're talking about population. They're just a little bit different. So since this is a sample of its times, we would say 10.8 for Rita, and I would have to pull it back up for Jose. And we're going to do this on down the page. Variance is the average squared distance each value is from the mean. So if this is the average distance, variance is the square of this. So variance is really the standard deviation squared, or it might one of those, because standard deviation symbol, sample, population, sample, population. Now IQR is within the middle 50%, and this is explained more a little later. So IQR, our quartile 3 is 35, our quartile 1 is 15. So for Rita, our interquartile range would be 35 minus 15. It's Q3 minus Q1. That's the interquartile range. But this we're going to do on later. So now we're going to visualize this data. So 25, $22, all right, so 25 would be here, 27 here, 28 here, 25 here, 22 here, 23 here. So if you see this, do you see the bell curve? Let's look at Rita's. 22, 23. Oh. Forgot I was having to go all the way up to 39. So I'm going to do 10, 15, 20, 25, 30, 35, 40. They did 5. So 0, 5. Alright, so Rita 25 right here, 35 here, 15 here, 11 here, 25 here, and 39 here. Is there much difference in the two of those? Now, I think on your paper, this is kind of... no? I must be thinking of something different. So, here we can't really tell a whole lot of difference in our data. I'm going to do this by the scale that's on your paper. Sorry, I don't want to start the video over. Alright, so 25 is here, 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 and here. Okay, so it does look a little bit different on, if you look at the different scales. This is really close together, but this is really spread out if you put them on the same scale, like by fives. So